All right, let's go ahead and get started. Thanks so much to those of y'all that are joining us here in Zoom. Thank you also to those of you that are joining us on YouTube Live. My name is Max Colley. I am the Program Manager for Public Engagement with Science at the Museum of Life and Science in Durham, North Carolina. This HeatWatch mini seminar is part of a much larger effort to build or co-create new scientific knowledge about urban heat and about extreme heat just in general here in North Carolina and even further from there. This evening, in support of that project and in support of the idea of building more public engagement around extreme heat, we are delighted to have some experts come on to talk to us about their work and about a way that you can get involved in building new scientific knowledge about this summer. So without further ado, I will turn it over to my friend, Dr. Angel Hsu, and let you do a better job of introducing yourself. Thanks so much for being with us this evening.
Thank you so much, Max. And I'm going to get started by sharing my screen, and it'll just take a second. Okay, as Max mentioned, my name is Angel Hsu, and I'm an assistant professor of public policy and the environment at the University of North Carolina, Chapel Hill. I also direct a research group called the Data-Driven Environmental Lab, and our mission is to apply quantitative, data-driven approaches to pressing and urgent environmental issues, including climate change. And I just want to caveat that I don't normally sound like this. I came down with a cold from my son, and so just bear with me, and hopefully I'll be able to make it through this presentation with a voice. And I also am very excited that I have two team members with me today, Shui Wang and Joyce May, and I'll let them further introduce themselves when I turn the program over to them to share a really exciting app that they've been working on that will allow you to also further contribute to scientific knowledge and understanding of how urban heat and heat in urban environments affects individuals. So to start, I was asked by Max to give some context for a recent study that we published in the journal Nature Communications that was looking at disparities in exposure to urban heat. And so just to start, to provide a little bit of context, we are currently living in what many scholars refer to as the urban century. And that's because if you look at population trends over the last half century, we can see that the percentage of urban population, so the number of people living in cities, has now surpassed the 50% threshold. And so now we have more people living in cities than not. And you can see that transformation of more and more of the world's surfaces being converted to built environments to urban areas, even here in this Google time-lapse image of where we live in the Raleigh-Durham area. And so I think that was a little bit quick, but maybe I can try playing it one more time. You could see that there's been quite a huge transformation and urban growth in this short amount of time. And at the same time, we can also see in this visualization that GDP has also increased primarily in these urban centers. Cities are known to be drivers of economic growth and prosperity. And so this is GDP, or gross domestic product, one of the indicators of economic growth as measured by satellite data, nighttime lights. And you can see the overlap between where people are living in cities and these bright white areas that are showing hotspots of economic growth and GDP. And what has been some of the consequence of this transformation? On one hand, urbanization, more people moving to cities, generating huge amounts of wealth and economic growth, has also at the same time led to what many scholars have referred to as the Great Acceleration. And so you can see socioeconomic trends here on the left in orange. And so increase in education and in population, and then also at the same time in green, the Earth system trends. So increases in pollution, air pollution, and nutrient pollution as well. And also increase in carbon dioxide emissions and energy consumption. And so now cities, even though they only occupy about 2% of the global land area, they account for, I mean, I've seen some estimates higher than the 70% of GDP, but also more than 70% of global energy consumption and 70% of greenhouse gas emissions. And so the environmental consequence and the climate change impacts of cities is thought to be quite significant. And we can also see that here in the satellite image of Washington, D.C. And so here on the left, you can see an aerial satellite image of the Washington, D.C. area with the downtown areas in white. And so these are the most urbanized areas, has the White House, for example, and a lot of the monuments that you may be familiar with. And then on the right, a satellite image of surface temperature. And so you can see that the hottest parts of the city here correspond to those bright white areas of built environment, of pavement, of buildings, cement and concrete. And that's in direct contrast to the green areas in the city that are also the bluer, cooler areas by way of temperature in the satellite image of heat. And so this difference between these forested, shaded, grass and tree covered areas and the built environments is referred to as the urban heat island effect. And so this is a schematic of what that essentially looks like. And so you can see that late afternoon temperatures tend to be much higher and hotter in cities, in urban areas. And they tend to, as you move out from a very dense urban core where you have tall buildings, actually Washington doesn't have super tall buildings, but you could think of New York City or even in downtown Durham, for example, or downtown Raleigh, are much hotter than areas as you start to move out into suburban areas. I'm here in Chapel Hill. I was really struck when I moved here in January how green it is. And so there's a lot of greenery, a lot of shade, until you get to the rural farmland areas that are predominantly grassland or more forested or vegetated landscapes. Those tend to be much cooler. And so this urban heat island effect, which we're talking about today, is a measure of how much hotter cities are than their surrounding environments. And so one of the questions that scientists have asked is trying to explain why urban areas tend to be hotter than their surrounding rural environments. And so there are several reasons for this. And so I pulled these slides from my climate change science class that I teach here at Carolina. And so first of all, urban areas are warm because of people. People live in cities and people have a tendency to generate a lot of heat through air conditioners, for example, which is what this first picture is showing. As air conditioners cool buildings, they have to actually expend and expel the heat to generate that cooling air inside somewhere. And so that goes outside into an urban environment. And then I have some pictures also from other areas where people use motorbikes or other forms of transport, such as cars, and those also generate a lot of heat. I'm sure that after you park your car, you put your hand on the hood of the car and it feels very warm. And so particularly in a dense urban area, all of that heat that's being generated just from running your car and combusting that fuel in your vehicle generates heat. And then there's a picture of highways. So in a dense urban area, they tend to be a lot hotter because of these anthropogenic or people-generated heat sources. Cities are also hot because of the way that they are constructed and the configuration of buildings. And so we refer to that as urban form. And so even the geometry and the layout of buildings can really affect the amount of heat and how hot an urban area is. So when you have tall buildings, for example, they tend to trap heat in between them and create urban canyons. And so when you have more densely clustered buildings and in a denser urban form, those can also generate a lot of heat because it's much harder for air to move between within a city to help dissipate and separate and spread out some of that heat. And also buildings and their configuration, their height, alter what is known as the sky view factor. And so here's my friend Winston Chow. He's a professor at Singapore Management University. And you can see he's in my class illustrating what a sky view factor is. So if you stand outside and you put your hands up and you take a look at the sky, it's a measure of what is obstructing your vision of that sky. And so you can see these fisheye images here of different cities. And so in some cases, They're almost completely unobstructed. And then in other cases, here's actually Singapore, where it's very green. And so when buildings, and you have a much smaller sky view factor, when buildings crowd that, then it's much harder, again, for heat to dissipate within an urban area. And so a lot of that heat gets trapped within these building structures in the urban form and make it much hotter than it would be otherwise. And then also the thermal and the physical properties of building materials and construction materials also impact how hot an urban area is. So I'm originally from South Carolina, and I grew up in Greer, South Carolina, in a brick home. And my parents were very thrifty, and so they never let us turn on the air conditioning in summer. And so the house would literally bake because it was this brick house. And then it was so hot, we would sleep on the floor because my parents didn't want to pay for the air conditioning. But if we had a house that was made of a different type of building material, for example, it might have been a lot cooler. And so these thermal properties of construction materials and buildings also have a huge impact on how hot an environment is. And so here's an illustration also in terms of the surface reflectance, or what we refer to as the albedo, has a huge impact on how hot an urban area is. So for example, asphalt and these darker surfaces, they absorb a lot of energy coming from the sun. And I'm sure you've all experienced in the summer, you get out of your car in a parking lot and you can just feel the heat radiating off that pavement. And it's because these dark surfaces, when we convert grasslands and vegetated landscapes to built environments, we're changing that surface reflectance and often making those surfaces more absorptive of the sun's energy. And same in terms of reducing I guess, converting a lot of previously pervious surfaces to impervious surfaces. So whereas grasslands and forest areas can soak up a lot of water and also help to then evaporate a lot of that heat in urban areas, and when you convert to impervious surfaces, a lot of that water just tends to run off. And trees also have a lot more evaporative ability as well, and they provide a lot more cooling and a lot more shade in forested or rural areas. And so that's one of the reasons why I'm sure you've walked also in summertime to different parks or down tree-lined streets, and they're much, much cooler than other areas that are exposed and are just pavement all around. So that's the context for urban heat and how cities are directly contributing to this phenomenon of local climate and global and warming in urban areas. But at the same time that we've seen the urban population surpass the rural population and more people moving to cities, we have also noticed a growing trend in inequality around the world. And so this is a map, a visualization of inequality in different countries as measured by the Gini coefficient, which is a measure of inequality between different populations. And so over time, in some places, inequality has worsened, and in other places, it's actually improved. In cities, and this is from our own data, cities have also become associated with being centers of inequality. And so we developed a Gini coefficient also for cities, looking at the differences in income distribution between different neighborhoods. And you can see in the US in particular, many large circles indicate greater inequality. This big circle here, I don't know if you could see my cursor, in South Africa, that's Johannesburg, where we found the greatest differences in income between neighborhoods. And you would see this all throughout the world, cities all throughout the world, as this map shows, not just the United States, but also in cities like Mexico City here. And these photographs that I'm going to show you are from Johnny Miller's, he's a photographer, his project called Unequal Scenes. And so you can see here that just a very thin highway separates a much wealthier neighborhood on the left from a much poorer neighborhood on the right. And here's another image also from Mexico City, where you can just see the stark disparities in the urban forms, as we just talked about, and the density and the construction of these different houses in these different neighborhoods in Mexico City. And then even more, you can see on the right, these really nice tennis courts and soccer pitches that stand in direct contrast to this much poorer neighborhood on the left in Mexico City, where they have this very informal soccer pitch. And then going back to Johannesburg, you can see informal settlements on the left directly contrasted to a golf course for even. So these scenes are common throughout the world and in cities. And so this is a challenge and a real priority that has reached the top of the United Nations Global Sustainable Development Agenda. And so Sustainable Development Goal 11, so there are 17 global goals that were adopted by all countries in 2015. And the Sustainable Development Goal 11 sets this charge for cities to be both inclusive and sustainable. And at the same time, they haven't provided decision makers or citizens the tools to actually know, well, is my city actually meeting this charge? Is it one of these large circles on the map that harbors a lot of inequality between people? Or is it one that's actually meeting this goal of trying to develop sustainable and inclusive growth and trying to mitigate inequalities between different populations? And so we developed an index called the Urban Environment and Social Inclusion Index. And I thought there was a link to the website here, but it doesn't look like it's there. But I'm happy to share that on the chat, or Shirley, if you can type it into the chat for everyone, that would be great. So this is a map of Charlotte, North Carolina. And on the left, we have tree cover percentage. And then on the right, there is the urban heat island as measured in degrees Celsius. And so you can see here that in some of the in the less covered and those neighborhoods with the fewest amount of tree cover, it also happens to correspond to some of the areas that are the hottest. And so even on a neighborhood scale, when you drill down into the 165 cities that we include in this index, we're seeing some really stark differences in the amount of access that people have to green space and to tree cover, and how much they're being exposed to urban heat. And we know that trees, as I just mentioned, are one of these mitigating factors for the urban heat island effect. And so they can provide a lot more shade and cooling. Trees also, they produce oxygen and they filter out harmful air pollutants. So not only are those people who are living in these neighborhoods at a disadvantage from not having a lot of tree cover, but they're also potentially more exposed to air pollution and to the effects of urban heat. And so the New York Times, not too long ago, late last year, published this story looking at some of these disparities in urban heat. And this is drawing from a study from the University of Virginia, or the Virginia Museum of Science, Jeremy Hoffman, who's a researcher and a scientist there. And he looked at over 100 cities and looked at specifically redlining policies that were discriminatory lending practices that prevented low income or communities of color from accessing capital that would have allowed them to buy homes in some of the wealthier neighborhoods of cities all across the Americas. So these practices, these discriminatory lending practices or redlining, he found tended to be associated with those neighborhoods that were the hottest. And so this story was really questioning whether or not these redlining policies were a type of environmental or climate racism, and relegating people and differentially to different exposures of urban heat. And so we dove into the literature and found that there were small scale case studies of this type of differential or disproportionate exposure to urban heat. But we wanted to ask whether or not these patterns were pervasive and persistent and systemic across America, or is it just isolated to a few examples or a few incidences? And so this was the question that we sought when we conducted our study that was just published, I believe this was last month. And so to do this, we looked towards data, and that's the name of my research group. And in particular, the advent and the huge amount of progress that we've made in using satellites and remote sensing and satellite measurement of urban heat. And so one of the challenges and one of the reasons why these small scale studies exist and have only existed in a few cities across America is that it's been challenging to get data on temperature, on air temperature. And so when cities have monitoring stations, it may be difficult to access that data. There may be differences in the instruments and how they're calibrated and how often they're maintained. And so it's very challenging to then consistently across many different cities, or even outside of the United States, for example, to collect that data to be able to understand what are the differences in urban heat exposure amongst different demographic groups and different populations in cities. And so we turn towards satellite data, which is measuring land surface temperature and the thermal properties of different surfaces, land surface types. And then we can take that land surface temperature data and, around cities and then compare it to the land surface temperature as measured by satellites in rural areas that are primarily forested and vegetated, and then just subtract the difference to get this measure of urban heat island. And because satellites consistently travel the world and orbit the Earth on a consistent basis, in some cases on a daily basis, then all of a sudden we've got a record, a consistent record that's measured of these differences in urban heat. And so you can explore all of this data for all 497 urbanized areas in the United States on our Google Earth Engine app here. So I included the link, and I'll share the slides with Max afterwards so that you can also, you don't have to scramble to get the link. But in this Explore, you can type in any urban area, any location in the United States, and access the urban heat island data that has been calculated using this satellite data, and also the US Census Bureau data, looking at demographics along the lines of income and also race and ethnicity as well, so that you can explore some of these trends for yourself. And so I'm just going to quickly talk about some of the key findings before passing it to Shruway and Joyce. So what did we find? Well, in this paper, we found that these patterns of urban heat island disparity are pervasive across almost every single major US city. So we focused on the 175 largest cities in the US with population greater than 250,000, so 250,000. And so here on the left is actually the distribution of average summertime, daytime surface temperatures for different demographic groups, and we compared. And so in panel A, the first figure, you can see that communities of color, people of color, are exposed to higher, on average, urban heat or surface urban heat island intensity than their white counterparts. And so you can see that almost a full degrees Celsius higher is the mean. It's a little bit hard to tell from these distributions here, but I'm happy to go into more detail if anyone is interested. And then the distribution almost looks virtually identical when you consider people who are living below the poverty line and people who are living 2 times above the poverty line. So low income people and people of color are both being disproportionately exposed to higher levels of urban heat than their counterparts in this example. And then in panel C, what's also quite interesting is that when you look at people who are living below the poverty line and people of color, those distributions are virtually identical. And then we also looked at age, but we didn't really see any significant differences between people who are over the age of 65 and those who are under the age of 5. And so those look pretty identical, except when you consider people of color who are elderly or very young. So I'm going to also give you a look at some of the spatial results too. So when we plot those differences here, you can see that in 97% of these cities, minority populations are exposed to higher urban heat island intensity than their white counterparts. So these are all the cities that are represented by triangles here. And that effect is particularly extreme in the larger triangles, actually in the northeast of the US, which was a surprising result to us because we figured that in hotter areas, maybe more arid or tropical climates, we would see those differences to be more extreme. But actually we didn't. We actually saw in the northeast that some of those differences were more extreme. So in all but 6 of the cities that we evaluated, people of color are exposed to higher levels of urban heat than their white counterparts. And the only exceptions were those that they just didn't have a high proportion of people of color living in those census tracts. So yeah, I should mention that all of this analysis was done by every census tract in all of these major cities. And then as I mentioned again, in 94%, so in almost all of the cities, people who are living below the poverty line are exposed to higher urban heat island intensity compared to people who are living 2 times the poverty line. And this is also, the US Census also designates that only 10% of people of color actually live below the poverty line. So this is not looking at low income and minority communities. This is just looking at low income communities, which actually include a lot of non-Hispanic white populations as well. And then, as I mentioned, roughly equal populations, in roughly half of the cities, people of color are exposed to higher levels of urban heat. And then in the other half, it's people who are living below the poverty line. So I know I'm running out of time, but I just wanted to emphasize one last point, is that the patterns of exposure actually vary by city. So this is actually my hometown of Greenville, South Carolina. And you can see here that the hottest areas of the city that are in red happen to overlap with those census tracts that have high percentages of minority Black populations living them. And they also tend to overlap with people who are living below the poverty line. But then if we take a look at Baltimore, for example, the patterns are very different. So the hottest parts of the city in red happen to be those downtown areas, but Black populations are more dispersed around the city. And same thing with those living below the poverty line. So the patterns are quite different. And then I've been getting a lot of questions since we released the study of, okay, well, what about redlining? Is this the cause of these disparities that you're seeing in urban heat exposure? And I say, well, we can look at some associations, but we haven't exactly established a causal link and to understand whether or not they are actually driving what we're seeing. But there is data. So this is a map of red line areas in Durham, North Carolina. And so a next step that we're going to take is to actually do a longer term analysis panel data set over time to try to understand some of these trends and looking at underlying socioeconomic drivers, also tree cover, as a potential explanatory variable to understand really what's been going on and what's driving these differences in urban heat. So our study is largely descriptive, but it's very clear that these patterns exist. And they don't just exist in isolated incidences or in particular anecdotes, they're widespread and pervasive. And so what can cities do? This is a question also I've been getting a lot. And so here are some ideas. First of all, increasing equitable access to green spaces and other environmental amenities. As we saw in our urban index, there are huge disparities in access to tree cover and green space for different neighborhoods by income. And so that's one particular planning tool that policymakers can work to implement. And then I think also utilizing tools like the urban index that we showed or the satellite data that we have in our Google Earth Engine app can help policymakers start to become aware of these potential disparities and then identify policies and strategies to try to ameliorate them. And then lastly, I thank you. And so I'm really excited about the study that Max is leading to engage many of you to collect more high resolution data, because the data that we have so far is measuring at the urban canopy, the surface. And so we need to have more data on the ground where people live to really understand how good that data is and where it's not and where are some of the gaps. And so the data that Max is collecting is incredibly critical to help better fine-tune these models and these estimates of urban heat. And also, I have a colleague who has developed a smartphone app called COZIE. And so I'm going to turn now to Shriwei and Joyce to tell you about this app and how we're hoping to also link this into the study that Max is also facilitating on the part of the museum. So Shriwei and Joyce, I will stop sharing my screen and let you share yours.
Yeah, sure. Hi, everyone. This is Shriwei. I'm a data science and DDL, so I'm interested in the environment study and also the data science and where those two areas intersect. So yeah, I'm really excited to introduce you the COZIE app. So basically me and Joyce working really hard trying to bring this to this campaign. And we're looking for how this app is going to work for the general urban heat island effect study. Joyce, you want to quickly introduce yourself while I'm going to set up to show the app.
Okay, hey guys, my name is Joyce. I'm a rising junior at UNC. So I'm very excited and honored to join DDL. I work as a student data engineer. And for this COZIE app, I mostly work on how to customize it on the phone side. So people can also use iPhone as well as their Apple Watch to answer the same question about this urban heat campaign. Yeah.
Great. Can everyone see my screen right now? So yeah, this is how the COZIE going to look like when you first enter. So this app is actually, we're trying to be, besides the, during the campaign besides people capture the temperature of your surroundings, we're also interested in how you actually feel about your surrounding, how you actually feel of your thermal environment. So basically, you can install this app on your iPhone, or if you have an Apple Watch, you're definitely welcome to use it on your Apple Watch. And then you can start it with register your account. Then let me quickly go through that. And yeah, this app will ask for your location. So this is really important for us to, really important data for us to collect, because we also wanted to know where you actually at when you feel either hot or cooler when you're out or indoor. And yeah, this is how the app will look like on the iPhone side. Basically, we have different task cards. So each participant are going to ask to finish each of these cards. So one thing we need to notice that the survey card is actually, we wanted the participants finish more than once. It's like when you're walking around during the campaign, then you can start to fill the survey once, and maybe after a couple, maybe after 10 minutes, you are in different places, then you can finish another survey about your feelings to the environment, to your surrounding. And then there's going to be some couple onboarding questions about your basic information, but definitely those information are going to be confident and only going to use for this study and won't be released to any other places. And so here's going to be really simple questions, starting from like how you prefer to be, and something like where are you indoor or are you outdoor, or what's the exactly surroundings you're currently at. Maybe you're at home or in the office, or maybe you're outside, you're on the you're in one of the park, or you're actually walking on the sidewalk. So that's related to other questions. For example, if you are indoor, then you're going to be asked, you have any of these equipment, for example, air, AC, or fans? Or if you are outdoors, then you're going to be asked, do you feel any, sorry. I think there's another question. If other questions that relate to if you're in the different cases, if you're outdoor, then you're going to be asked, are you under the sunlight, or if you're actually hiding under the shade, which could be really nice in the heat during the warm summers. So this is how the Apple iPhone side is going to look like. And I'm also going to show you how, if you wanted to finish survey on the Apple Watch side. So this one is actually a lot cuter and much more easier. So this really cute and nice looking icons. Basically, you're going to answer the same question. So the good part of this app is while we can letting people answer those questions and surveys, if you are using an Apple Watch, then the Apple Watch is also going to record some of your health data, like the temperature or heartbeat rate. While if you're using the iPhone side, then we're also going to capture your location. So this is like extra data to support getting more ground level information related to the urban heat study. So yeah.
Thank you so much, Joyce and Sherway. So the idea of this app is to be able to better understand human scale impacts of urban heat. So it's one thing to take this data and measure it from a satellite, but we're to understand more how it actually affects people on the ground, and if there are differences or correlations. As we know that sometimes you could be outside and it could be 95 degrees outside, but then if you walk under the shade, it's much cooler. And so do people actually perceive those differences? That's what we're interested in. And so this is a really interesting open source app that my colleague Clayton Miller at National University of Singapore developed, and Sherway and Joyce have been working on a version for the iPhone as well to complement the study that Max will tell you about in a second. And so we're really excited to work together to pilot this for the first time in a North American context. So Max, I'll pass it back to you.
Hey, Dr. Shuwei, Joyce, thank you all so much. We're really, really grateful and excited to also be piloting COZIE in this context as a part of this project. And I'm actually going to turn it over to my friend Chris Goforth from the Museum of Natural Sciences to tell you a little bit more and to invite you to join our project.
All right, thank you, Max. We are very excited to be part of a large partnership of local organizations in the Raleigh-Durham area that are leading the charge to map about 130 square miles of urban area in our Raleigh-Durham areas. This project is made possible by the National Oceanic and Atmospheric Administration, the National Integrated Heat Health Information System, and the National Weather Service, and it's happening in about 11 other states this summer as well as ours. So on one very hot day this summer, we don't know exactly which day it will be, but it will be a very hot day. We're going to send out a horde of volunteers, people like you in the audience, who are going to attach monitors to their cars, their bicycles, or even themselves, and then move those monitors around so that we can get a better idea of what the heat patterns of our area look like. And we really need your help to do this. We know that these patterns are really heavily influenced by the built environment in our cities, like you just heard, how much green space is available, how many impervious surfaces are present. But a lot of this is unfortunately the result of very racist planning and policies within our cities. We know that these urban heat impacts are disproportionately impacting certain areas of our cities and the populations that live there. And so we want to gather these data, but we also hope that this project will help build public knowledge of these issues and a political interest in mitigating some of these issues as well. So we hope that you'll consider joining us as project volunteers. We will put a link to the project sign up page in the chat. But the link, in case you are not watching this live, is climate.ncsu.edu/research/UHI. And you can go there and get signed up. Now that you've learned something about the science and the impacts of urban heat islands and urban heat effects, we hope that many of you will consider joining us so that we can measure our urban heat and maybe make our cities a little bit more climatically equitable for everyone. All right, thank you everyone so much for coming tonight, and I'm going to turn it back over to Max to wrap us up.
Most excellent. Thank you all so much for joining us this evening. Thanks, of course, to our guest panelists for lending us your wisdom, knowledge, and expertise this evening as well. We are really looking forward to getting to know all of you all through co-creating this knowledge together. And like I said, I'm especially grateful to you all here this evening for building COZIE along with us to be able to prototype that alongside this study this summer. So thank you all so much. That does it for this evening's program. Have a good rest of your evening from my cat as well, I guess.
I love the cat cameo. Thank you so much, Max. Thanks so much for organizing. And thank you everyone for listening.